Welcome back to another Die-Hard American Metal Explainer. Today we're going to get right into the heart of manufacturing. I mean, the real soul of it all, the die. We're going to look at how it's evolved from this hand-scraped piece of art to a five-axis science.
So what's the deal with die making today? That's the big question, right? For every single American manufacturer watching this, it's a huge deal. Is it all about that old school craftsman's touch, that intuitive feel? Or is it just about the engineer's computational code? Well, as we're about to see, the answer, it's a lot more interesting than just picking a side.
All right, first things first, let's make sure we're all on the same page. What is a die? Well, think of it as the master tool. It is the absolute heart of the stamping process. It's what gives form to millions of metal parts out there, from the huge body panels on a truck all the way down to the tiniest little electronic components. It's the engine of repeatability.
So here's our game plan. First, we're going to talk about why the die is so central to everything we do. Then we'll dive into the pure art of the analog craftsman. After that, we'll jump into the science of the digital revolution. And then, this is the good part, we'll see how the best shops are merging those two worlds. And finally, we'll figure out what it really means to be a toolmaker today. Okay, let's get into it. The whole idea of modern high-volume production, it all hinges on the die. And this concept isn't new. It goes all the way back to Eli Whitney and his whole vision for interchangeable parts. The die is the physical proof of that vision. It's the tool that makes sure the 10,000th part is a perfect twin of the very first one. It really is the unseen engine of it all. Now, I want you to take a step back in time with me. Picture the traditional tool room. This wasn't a place with software and simulations, no way. This was a world that ran on sensory feedback, where the connection between the maker, the machine, and the metal was direct, it was physical, it was completely unfiltered. This quote just nails it. The veteran machinist, they weren't relying on lines of code, they were using their senses as this incredibly high-bandwidth, real-time data processor. The sound of the cut told them if the tool was getting dull. The color of the chip, that perfect straw blue, told them the feed and speed were just right. The feeling through the cast iron frame, that warned them of chatter before it ruined the part. It was a physical conversation. And the tools they used, they were pretty straightforward. Mills, lathes, grinders. But the skill it took to make them sing, that was immense. You see, the craftsman was a conductor, not a programmer. Every single turn of a hand wheel, every tiny adjustment, it was a direct physical act, guided by that constant flow of sensory information. And this is where the art form is just unbelievable. Hand scraping wasn't just for looks. See, you might think a perfectly ground, flat surface is what you want, but you'd be wrong. It's too perfect. It wipes away oil and can cause parts to seize up. By painstakingly scraping away these tiny high spots revealed by the blue, the craftsman created this perfect landscape of flat peaks and little valleys. And those valleys, they held the oil, making sure the die would run like a dream for millions of hits. This kind of expertise, it wasn't written down in a textbook. It was passed down through stories and hands-on wisdom, what a lot of us call tribal knowledge. A master toolmaker could look at a simple 2D blueprint and, in their mind, see exactly how the metal was going to flow, stretch, and compress. They could predict springback and build compensation right into the die by hand. It wasn't magic, it was a science built on decades of trial and error. All right, so we've been in this world of feel and sound and intuition. Now, let's shift gears and jump into a completely different universe. One that isn't driven by feel, but by data, by software, and by just raw computational power. This is the big leap from the craftsman's intuition to the engineer's analysis. And this revolution really started when we went from physical blueprints to 3D solid models in CAD. But look, this was so much more than just swapping a drafting table for a computer. It was a fundamental change in philosophy. You went from a physical first world where you found problems on the shop floor to a digital first world where you could build, test, and assemble the entire die virtually. This new digital way of doing things raised an absolutely game-changing question. What if you could perfect the entire forming process before you ever cut a single chip of steel? Could you just eliminate all that expensive, time-consuming trial and error that was just part of the deal in the analog age? Well, the answer is forming simulation software. And honestly, it's like having a digital crystal ball. You feed it the part's geometry, the material properties, and you can run a completely virtual tryout. The software tells you exactly where the part might wrinkle or split or thin out,
And, maybe most importantly, it calculates springback with incredible accuracy and automatically creates a compensated die surface to fix it. So, you've predicted the future, now you have to actually make the thing. And that's where the execution comes in with absolutely breathtaking precision. A modern 5-axis CNC can hit positional accuracies of 15 micrometers. Now, to put that in perspective for you, a human hair is about 70 micrometers thick. We are talking about a level of consistent, repeatable precision that is it's physically impossible to do by hand.
Okay, but here's the thing. And if you take one thing away from this whole explainer, let it be this. The best shops, the ones that are really winning, they aren't choosing one world over the other. They're not throwing away the old skills for the new tech, no. They're building a powerful strategic bridge between them. And you see this synergy at every single step. Just take the tryout phase, right? The simulation gets the die, 90% of the way there, which is amazing. But it's that experienced die maker who dials in that final 10% in the press. They spot the subtle little issues the software missed. It's this incredible combination of predictive power and practical, hands-on wisdom. And this is what I call the ghost in the machine problem. Because simulation is an amazing model of reality, but it's not reality itself. When a die that was absolutely perfect on the computer screen starts failing in the press, the software can't tell you if the new batch of steel is a little off or if the press is deflecting weirdly today. That's when the craftsman's gut feeling becomes the most valuable tool in the whole shop. So all of this synthesis of skill and technology, it creates a brand new kind of professional, a new ideal, really, for everyone in our industry, and that's the hybrid artisan.
So what does this person look like? Well, the modern American toolmaker, they're basically bilingual. They have to be fluent in 2 languages, digital and analog. They need to be able to look at a complex simulation report in the morning and then walk over to a manual mill and whip up a quick fixture in the afternoon. They are the essential reality check that keeps all these digital designs grounded in the physical world.
And this brings us right back around to that first question we asked, art versus science. And you know what? It was the wrong question all along. It's a false choice. This craft was never just one or the other. It's always been about the unbreakable link between the two. The art of the trade has just evolved. The soul of the die, it's not in some nostalgic past, and it's not in some purely digital future. It is right here, right now, in the dynamic fusion of these 4 things. The power of predictive simulation, the flawless execution of CNC precision, the absolute, irreplaceable value of hands-on skill, and the veteran wisdom that ties it all together. So I'm going to leave you with this thought. The future of American manufacturing, it doesn't belong to the old-school craftsman who refuses to change, and it doesn't belong to the young engineer who scoffs at the past. It belongs to the hybrid artisan who gets the best of both worlds. So the question for you is, where are the bridges in your shop right now, and what's the next one you need to build?